In this lecture, we will discuss about application of principle of superposition. The principle of superposition allow us to form a state which is the superposition of any number of states, that is psi which is written as and read as wave function, and this can be written as psi is equal to a1 and psi 1 plus a2 psi 2 plus a3 and psi 3 plus up to so on. Okay, and this can be written in summation form just like as it is ai and psi I, where I is equal to 1 to n. Okay, and remember that over here by the principle of superposition, ai mod square absolute square should be equal to 1, corresponds to probability of finding a particle in the state represented by psi I. Similarly, ai absolute square corresponding to probability of finding a particle in state represented by psi I. Okay, so this means that when we want to establish a wave function, when we want to find a wave function, then this condition must be satisfied. This condition, ai absolute square should be equal to 1. So to check that whether a function is a wave or not, wave function or not, then what we do, we will check this condition, ai mod square is equal to 1. To understand this principle of superposition more clearly, we will take some examples. Identify whether or not the following state is acceptable. So the condition that we have read before in the principle of superposition, where ai absolute square is equal to 1, that condition will be used over here. Okay, so when we compare, then we can see that here a1 is equal to 1 over 3 square root. Okay, and in the same way a2 is equal to 2 over 3, and a3 is equal to, this is equal to 2 square root and divided by 3. So by the principle of superposition, we want to check that either this function represents a state or not. Okay, state means that wave function, either this function is acceptable for a wave function or not. Every function is not a wave function. If this condition is satisfied, then it is a wave function, otherwise it is not a wave function. Okay, so there are a lot of functions in mathematics, in calculus we study, but every function does not represent a wave function. Yes, of course, a wave function can be a wave function if this condition of principle of superposition, ai absolute square is equal to 1. So which means ai square, ai absolute square, and you know here the value of I is equal to, this is 1 2 3, and we can write it just like as a1's absolute square plus a2 absolute square and plus a3 absolute square. Now putting the value over here, the value of a1 is 1 over 3 square root square, and the value of a2 is 2 over 3 square. In the same way, the value of a3 is 2 square root over 3 square. Okay, and this is equal to 1 over 3 plus this will be 4 over 9 and plus this is 2 over 9, and so 9 is the LCM. This will be 3 plus 4 plus 2. So this is 9 over 9 and this is equal to 1, which means that yes, it is acceptable. Here you can see that either it is acceptable or not acceptable as a state, whether or not following state is acceptable. Yes, this state is acceptable because it represents a wave function. Why it represents a wave function? Because it satisfies the condition of superposition. It is equal to 1. If it is equal to 1, then this means that this function is a state. State means that this function is acceptable as a state. What does it mean by state? State means that this is a wave function. This is a wave function. Okay, in quantum physics, the meaning of wave function in quantum physics, not every function in calculus represent a wave function, but any function that represents the principle of superpositions, that is acceptable as a wave function. There is another example. In this example, we will check that either this function represents a state or not. Okay, yes, if it satisfies the principle of superposition, then it will represent a state. Otherwise, it will not represent a state. Here you can see that if we compare, then the value of a1, okay, the value of a1 and a2 and the value of a3. So the value of a1 is 4 over 7 square root. Okay, and in the same way, the value of a2 is 2 over 7 square root. In the same way, the value of a3 is 8 over 7 square root. And we know that summation ai and ai absolute square, and the value of I is, of course, it is 1 2 3. It should be equal to a1 absolute square plus a2 absolute square plus a3 absolute square. Now this is equal to, the value of a1 is 4 over 7 square root, 4 over 7 square plus this is 2 over 7 square root, this is square plus 8 over 7 square, and this will be equal to 4 over 7 plus 2 over 7 and plus 8 over 7. And since 7 is the LCM, therefore this will be equal to 4 plus 2 plus 8 over 7, and this will be equal to 2, and of course this is not equal to 1. So this means that this state is not acceptable. This is not acceptable as a state, which means that this is not acceptable as a wave function, because our answer is equal to 2. This is not equal to 1. So the principle of superposition is not satisfying over here. If the principle of superposition is not satisfying over here, then this means that this is not acceptable as a state. This is not acceptable as a wave function. Orthogonality in quantum physics. These words come from two Greek words, ortho, which means perpendicular, and gona, which means angle. Check this integral, which is minus infinity to plus infinity psi I steric and psi j dx is equal to 0. Here psi I and psi j are two wave function. If this condition holds, which means integral of psi I and psi j with respect to dx is equal to 0, then we say that these two wave functions are orthogonal to each other. There is another condition which is called normalization. So orthogonal and normalization of wave function is usually represented by this integral, which is minus infinity to plus infinity psi I steric psi j dx is equal to del ij. Here del ij is called conical delta, and the value of this conical delta is equal to 1 when these two wave functions are identical, and this is equal to 0 when the wave functions are not identical.